All right, so the next thing that we're going to do, we're just going to go back to Canvas, and under Canvas, let's go to Modules. And under Modules, I'm just going to go down here and now select the descriptive statistics of the radius. So this is going to be fairly easy, and I will be going fast. You can read these directions. We're going to use this formula right here. You definitely want to relate it back to descriptive statistics reference. We're going to use the analysis tool pack. So I'll give you a few more things, okay? But it's pretty much what we've been saying. So I'm going to go ahead and open up this package here, and let me see. So I say got it, and download. So once we download that, I can go to downloads and open up the very last thing. Wrong. Let me do that again. Where are you? Download. So I'll open up downloads this time. It should be at the very top. There we go. So now we have our radius homework. So I'm just going to go ahead and type in radius here and know that this is in meters. All right. After the radius, we want the normal distribution of the radius. All right. And then after the normal distribution, we're going to have statistics, just like we've been doing. And it's the, I like the parametric results. All right, so I'm just gonna wrap this, and let's center a middle and center it. So this is what we're going to do. Let's go ahead and find the radius. Radius is going to be equal to, and you guys probably can't see all this. Let me make this bigger. All right. Hopefully that's big enough for you. We're going to say equal to SQRT. This is Pythagorean's theorem. And so square root of the power. And we're going to take x, comma 2, go out of that and say plus. Oh, no, you didn't. No, we're going to go on the other side and say plus power of y, comma 2. All right, so this is the radius. I'm going to fill that down. I'm going to go ahead and get our normal distribution. Before we get our normal distribution, we're going to need our parametric results. So let's do it. Let's go to data, data analysis, descriptive statistics. L is, or this is going to be C. And then we have our labels in the first, output range. We need to choose what that's going to be. And it's definitely not going to be there. So this is where it's going to be right here. And yep, everything else is good. So now we have our mean and our median. The mode is not occurring in the standard deviation. So the things that we're going to need for our normal distribution, again, will be this mean and this standard deviation. So now we can do this, the normal distribution, norm dist. We'll select our radius and we'll hit comma, and we want our mean. That's function F4, comma, and we want our standard deviation, function F4, comma, and this is just going to be false. So false the function, false will come up, logic function. And I'll hit return. So now we know the normal distribution. So I'll just select both of these. And, oh, but radius is a calculation, as you can see. So we don't need that as a calculation. So I'll insert, copy radius, and then paste radius with the special function, and we're just going to choose values only. All right, so now we'll take these two. Now, before we take those two, I have to make sure that we're referring to the appropriate rate, the appropriate things in here. So we need to change C2 to D2. Everything else remains the same. So we're going to go ahead and take the radius and the normal distribution. We're going to insert. Once we insert, we're going to use smooth curves. Look at that. Woo! That's beautiful. Since we're here, let's go ahead and pop that axis title in there, primary axis, and let's do the same for the primary vertical. Let's change these labels so we know what's on the x-axis. It's the radius. And that's in meters. Oh, no space. So right here, I have, we have the normal distribution. Distribution. So we need to basically, what do you call it? Sort. So we're going to sort from smallest to largest on these two, and our curve becomes like super smooth. Now this is, oh, that's the normal distribution. Now the problem is did I take a sample? Nope. So what I'm going to do is I'm going to go back. I want to take a sample in here. Let's go from 25 to 75. I'll just choose this as our sample. I'm going to copy that, and then I'll paste that over here. Paste special. Is that what I want? Yeah. Paste special values. Say OK. So that's the wrong one. Okay. So these are the radius sample. Okay, it's still measured in meters. So I'm just going to go and actually do the sort right now. And that's going to be from smallest to largest. And you should see the graph clean up. So this is our normal distribution. Now we're about to take the statistics or a sample. And so I want to do the same thing, normal distribution. Copy it, and then I'm going to go here, paste normal distribution of the radius. So this is referring to everything properly. Let's go ahead and graph this. And this is what we have. So it doesn't look like it's making a really good normal, but this is what it is. What it is. So we're going to need to sort these two. All right, and so when we do that, we're going to get a fairly smooth curve here. It's not, well, this is the normal distribution of this data set. So if we, I'm using the wrong mean and mode. Brass. Statistical results. So I'm going to make those merge. So that was a boo-boo. And I'm just going to drop my data analysis pack in there. Boom, boom, boom. All right, that's sweet. We have everything else set except where it's going to go. And I am just going to place it right over here. So I say equals to. Open that up. This time we want to use these two. I'll give them a different color. And standard deviation. So those are the two that I'm talking about. So now we want to graph this based on this information as opposed to this. So we have G4. We need this. I need to get the function key in F4. And so $G8, this one is going to be N8. Makes sense. So I'm going to stop on N8, boom, and then I'm going to do my function key, function 4. And so function 4 on the IBM, and function, there's a function key in the lower left-hand corner for the Mac, and F4. So that'll do it for you. Cool beans. So now we have all of that taken care of. Let's go ahead and convert everything. Let me see if this thing graphs something different. Oh, nice. Ooh, man, that's some sweet love right there. Hot dog. Now let's look at the mean. Let's compare those two. See that? So I'll just drop all three of these into scientific notation for easier readability, and I'll do the same here for the same reason. And so that's scientific, and then you have this one, and it's going to be scientific as well. So we have everything over there. Now let's do the same here, and this is going to be scientific. And these, well, not that one, but that one. Whoo! Scientific. And I'm just doing this again so we can read it. All right, so the mean is 1.77. The mean over here is 1.75. The standard deviation is 0.00434, and the standard deviation over here is 1.47. That's different. Okay, pretty different. So we can do some other things by comparing the two. So I better finish this up. I'm going to go ahead and go to our chart design, and I'm going to add two labels, primary X and primary Y, or the vertical and horizontal. What we know about this is that it is the radius, and it's measured in meters. And what we know about this is the probability. Normal distribution. Oh, excuse me. All right, that's pretty much it. So let me stop this show. All right.